The lung disease tuberculosis is still one of the world's top 10 causes of death. And while it's completely treatable, the patients need constant monitoring to make sure that the treatment is actually working. And that monitoring is pretty labor intensive. Somebody needs to take a sample of their phlegm and count the bacteria in the phlegm by eye under a microscope. So that's a real bottleneck. And now some engineers from Cambridge Consultants have been developing a technology to burst through that bottleneck using AI, as I, Phil Sansom, found out from developer Matthew Murchie.
So what we've done is we've attached a standard smartphone to readily available microscopes. That's the kind of microscope you'd find in laboratories in developing countries. And what it does is that it uses an artificial intelligence algorithm to look at the images and detect the bacteria and count it automatically. It speeds up a bottleneck at the moment, so you can get probably a 10 times increase in throughput, which means you get 10 times more patients being able to receive good quality treatment and be treated for tuberculosis.
How well does it work? Can it actually accurately count the bacteria?
So it can. So we're focusing on sensitivity over specificity, and the reason is you don't want to miss any TB. But if you catch a few extra, which turn out not to be, that's not a bad thing because you want someone to be able to look at it. So it's an AI assist tool at the moment. It doesn't perform the diagnostics for you, but it means that it speeds up the process massively.
And are we talking a machine learning algorithm like we've seen before? Like it looks at a bunch of other samples and it learns from that, and then with new ones it can figure it out?
Yeah, exactly that. So we have not told it what a bacterium looks like. Not at all. What we've done is we've taken a few thousand images and told it to look out for similar things. And the advantage of that is the images are quite complex. You get things like overstaining, other cells, other bits and bobs, proteins, glutinous stuff in the slide, and the bacteria sometimes clump together. So being able to just show it what bacteria look like without telling it what to look for is really valuable. What also means is that there are other ways to stain bacteria, or maybe you want to detect other types of bacteria. You don't need to write an entirely new algorithm. All you do is just provide it with new training data, and it learns to pick up the new features.
You said this solved a bottleneck. How much quicker actually is it then?
Yeah, so just a clarifying statement, there are still manual steps involved. So collecting the sample is still manual, preparing the slide by staining it is still manual, but one really labor-intensive process is looking down the microscope and counting it. So to give you a broad idea, there's a massive amount of variation, but it takes, say, 40 minutes or so to look through a single person slide. With this system, it could take 5 minutes. So
that's a pretty big improvement.
Yeah, so it's an 8 to 10-fold improvement for that particular step, and you may want to have someone reviewing any data which looks a bit anomalous, but in general it should just spit out a number, tells you how many bacteria there is, and that's the counting job done.
So when is it going to be ready?
So this is not a product, this is very much a proof of concept. At the moment we've been using a surrogate bacteria and artificial spit sample. The next step would be to collaborate with a university to get real-world data and then do a retraining and see how well it performs on actual spit samples from patients.
So promising if it works, but let's wait for them to test the tech on real TB patients. Matthew Murchie there from Cambridge Consultants.